welcome to A1 Tutor Live class. And now we are going to be having mathematics. Once again, welcome to A1 Tutor Live class. Okay, so let's kick start today's work. Last week, or probably let me say yesterday, we concluded the topic arithmetic progression. We had the part one, then yesterday we had the part two, which was basically on solving UTME question. And the first part of the arithmetic progression was basically on explaining the concept and also explaining the hints and the necessary knowledge that we need to know about the formula involved in arithmetic progression. So today we are going to take geometric progression. Okay, we have done arithmetic progression, and today we want to look at another one called geometric progression. Geometric progression. So that's what we are looking at today. Geometric progression. Like I used to say that mathematics is real and it can be traced back to our real life activities. Yes, mathematics can be traced back to our real life activities. It's not just an abstract. It's something that can be real, or let me say something that we can actually experience even in real life. Okay. Now, geometric progression. How do we introduce the topic geometric progression? Now, let's say we have a student who happens to have a pocket money from his parents on daily basis, all right? And he decided to go through a process of saving. That is, he will be saving a certain amount of money based on the pocket money he's receiving on daily basis, all right? So on day one, he decided to save a particular amount. This is day one. On day one, decided to save a particular amount. Day two, decided to save a particular amount. Day three, up to day four. Now, if on day one he said, I'm going to save 100 or US dollars, 100 US dollars, then in day two, he said, okay, I'm going to double the money I saved on day one. So, which means he's trying to work with a progression, which is going to be in an orderly manner. He decided to be doubling the money he saved on each day for the next day. So he saved 100 US dollars on the first day. So on the second day, he decided to double the money he saved on the first day. So the second day, he saved 200 US dollars. So on the next day, which is day three, he also decides to double again. So now he's going to have 400 US dollars. And what do you think he's going to have in the next day? What he's working with is working with the double principle. That is doubling the money he saved a day for the next day. Now, if he's having 400 US dollars on the third day, what's he going to have on the fourth day? Of course, the double of 400, and that is 800 US dollars. Now, when you look at this sequence, you will see that there is a progression from the word geometric progression. There's a progress in the saving process because this guy decided to double the savings for day one by two. That is, he wants to double it, multiply it by two, and save it for the next day. So if he continues like this, that means he has agreed to work with the doubling system by doubling the money he saved on a day for the next day. So this example is actually a good example of geometric progression. Now, after a long while of saving, by using the double system, that is the doubling system, now the guy has all this money with him, and it's wow. So I've kept this so much. Why? Because he was able to implement what we call geometric progression. Geometric progression. Now, if you look at this money, you'll see this is not like looking at the thickness of the money. This is not much. This is much, and this is much more than what we have here. So let's say this is 100, and this is 200. Now this is 400. This is 800, and this will be what 1,600 US dollars. Then when you go again, you have 3,000 US, 3,200 US dollars. So because the guy is doubling the money, he's doubling the money. So at the end of everything, when he checks his savings, he'll be like, wow, I kept all this money. Awesome. It is so because he followed what we call geometric progression, as the name implies. This is just a kind of scenario that can be used to explain the concept of geometric progression. Geometric progression. So if you look at this, the guy was able to save money using a doubling system. A doubling system. So this is what we call geometric progression. Geometric progression. Now, when you look at this, there's something we call common ratio, which we are going to discuss when we continue with the topic. We're going to discuss what common ratio is. But let me use this illustration to explain what common ratio is all about. Now, in geometric progression, we also have the T1, which is the first term, the second term, the third term, up to the nth term. Now, the first saving let's take the first saving to be T1, the second saving to be T2, T3, T4, T5, then T6. Now, if I'm going to get the common ratio of this particular geometric progression, I'm going to say ratio, which is R, equals to T2 over T1. That is 200 over 100. And when you divide this, you get 2. Now, why is it called common ratio? If I'm going to use another term again, I'm still going to get the same 2. And that's why it's called common ratio. It's common to all the terms. It's common to all the terms. And these 2 here represent the doubling system. That's double of the money that he was saving. Now, let's take T5 and T6. So, common ratio is T6. We have the highest up over T5. T6 is 3,200 and C5 is 1,600. When you divide this, we still have what? 2. Still what? The doubling system. So this is actually a perfect example of geometric progression. A saving system of double, probably triple. You can decide to make the money triple. Okay? Instead of doubling system, you want to make it triple. That is, if you save 100 naira on day 1, you'll be saving 300 naira on day 2, or 100 naira 100 US dollars on day 1, then on day 2 be saving 300 US dollars. That's triple, triple. But what this guy was doing was double. And you can see, look at the expression of the guy. Wow. Who will see all this kind of money? I will not be marveled that, wow, I've kept this so money. I've kept this money to this extent. Wow, this is a great savings for me. You get? So that is geometric progression. So that is the concept behind geometric progression. So we are going to dive into the topic proper by taking the formula. We need to understand the formula of geometric progression. We have 3 formulas in geometric progression, and we need to understand them, using them to solve some questions. And we'll proceed ahead in the next class to take evaluation question using the UTME question. Okay, thank you for listening. We continue with the topic in details now. We've explained the concept. Now let's consider the topic in details. Sorry if this is the first time that you are watching our video. Please do well to click on the subscribe button. If this is the first time you are watching our video on YouTube, please do well to click the subscribe button so that you are going to have notifications of our videos as we are uploading them. And please do well to share, to like, and to comment. The comment section is there for you. Please feel free to express yourself in the comment section. If you have questions based on the topic you are watching, which is geometric progression, do well to drop your question in the comment section. All right, and do well also to like. The more you like our video, it makes it the YouTube algorithm makes it available to anyone that search for that topic. So do well to like our video, comment, and share. Do not forget, you need to subscribe. All right, now let's go to the main work, geometric progression. I'm going to stop presenting this picture Then we are going to take the topic in detail. The topic in detail. Geometric progression. We are working on the topic geometric progression. Geometric progression. Geometric progression. Okay, what is geometric progression? Let's have a definition for that. Definition for geometric progression. Geometric progression is a form of sequence, is a form of sequence. You know, we explained sequence in the first part of this topic, which is arithmetic progression. So if you don't understand the concept behind sequence, please do well to watch our video on arithmetic progression part 1. Part 1, you're going to have the details of what a sequence is in that video. Do well to get the knowledge from there. It's a sequence which has a common ratio, between any of the term and its preceding term. Its preceding time. Its preceding terms. So we said geometric is a form of sequence. It's a form of sequence because we have the linear sequence, which is the arithmetic progression, and also we have the geometric progression, which is also known as exponential sequence. Take note, another name for this is exponential sequence. So it is a form of sequence which has a common ratio between any of the term and its preceding. Preceding means the terms before it. Okay, so now let's see an explanation for that. The definition, I have 2, I have 4, then I have 8. Now for this expression, we should all know that this is called the first term, T1, and this is the second term. This is the third term. All right. Now we want to understand what they mean by common ratio. Common ratio between the term and the terms that precede it. So if this is T2, this is T1, let's get the common ratio, which is R. Common ratio is T2 over T1. Not T1 over T2, but T2 over T1. So T2 is 4, T1 is 2. So the answer is what? 2. Now to confirm that it is a common ratio, let's take T3 and T2. R equals to T3 over T2. That is 8 over 4. 8 over 4. And when you divide that, you have what? 2. So the common ratio of this particular expression or illustration is what? 2. The common ratio is 2. The common ratio is what? 2. So now, when we understand the common ratio, we can go deep into the topic by considering the nth term of a GP. Considering the nth term of a GP. Considering the nth term of a GP. Now let's consider that the nth term of a GP. We are going to wipe the board. So the nth term of a GP the nth term of a GP. The nth term of a GP is given as Tn equals to AR n minus 1. Tn equals to a r raised to power n minus 1, where n is number of time, a is T1, that is the first term. Then we have R is common ratio. So this is the meaning of the formula for the nth term of a given. N is the number of times, T1 is equals to A, which is the first term, and R equals to the common ratio. The common ratio. Now let's see how this works by solving an example. We have an example here. Find the seventh time. Find the seventh time of A. Find the seventh time of A geometric progression in 6 and its common ratio is 3. Find the sixth term. Find the sixth term. So we have the common ratio to be R equals to 3. From the question, we are given the common ratio, and we are asked to find the seventh of a geometric progression, the seventh term of a geometric progression in 6. Find the seventh of a geometric progression in 6, and its common ratio is 3. So the geometric is 6, not in 6, but 6 is 6. So that means C7 is given to be 6. C7 is given to be 6, where Tn equals to Rn minus 1. R minus 1, n minus 1. So here, the 7 is equivalent to n. So we have T7 equals to ARn minus 1. A representing the first term. And in the question, we are not given the first term. We are not given the first term. All we are given is the sixth term. We are not given the first time. So if you are given this if you are given the common ratio, which is R equals to 3, now we have to solve to get the seventh term. We have to solve to get the seventh term. That is AR n minus 1. If n is not given but R is given, that's A into bracket. R is 3 into the bracket. 7 minus 1, which is A times 3 raised to power 6. A times 3 raised to power 6. Then we'll proceed to simplify this. That A times 3 raised to power 6 is going to give us a particular value. But before that, T7 is 6. T7 is 6. So we have 3A raised to the power 6. We have 3A raised to the power 6. Dividing both sides, by 3, dividing both sides by 3, we have we have 6 over 3 equals to 3a raised to power 6 over 3. Where 3 we cancel 3, 3 here 2. We have a raised to power 6 equals to 2. A raised to power 6 equals to 2. A raised to the power of 6 equals to 2. And to get the answer of A, we need to take the sixth root of A equals to the sixth root of 2. So by simplifying this, we have the sixth root of A, the sixth root of A. This 6 here cancel the sixth root. We have A equals to the sixth root of 2, the sixth root of 2, the sixth root of 2. That's going to give us 1 point something. That is having a decimal value, having a decimal value, or better still, we can still express the final answer as what we have here. We can express the final answer as what we have here. We can express it as the final answer as what we have here. So that is going to be 6 equals to A multiply 3 raised to power 6, making A subject of the formula. A will be equals to 3a raised to power, A will be equals to 3 raised to power 6 divided by 6. That will be 3 raised to power 3 raised to power 1 over 6. And that is A raised to power 6 equals to 1 over 2. 1 over 2. Let's check this if, okay, let's clean this. We need to correct this. All right, we need to correct this. There's a little error here. Okay. Okay, let's proceed from here. We said T7 okay, so we are having the first term. The question is wrong from the onset. It's supposed to be the first term of an AP. Permit me to wipe the board. The first term of a GP. The first term of a GP is 6. And its common ratio is 3. Find the sixth term. So that's the question. Find the sixth term. So solution, we have A, the first term is 6. R, the common ratio is 3. So to find the sixth term, that is T6 equals to ARN minus 1. Take note where n equals to 6, because we have to find the sixth term. So n will be equals to 6. That will be T6 equals to A, which is 6, into the bracket R is 3. raised to power n, which is 6 minus 1. That is T6 equals to 6 in brackets. Subtract 1 from 6, we have 5. We have a 3 raised to power 5. And that is T6 equals to 6 times 3 raised to power 5. When you simplify this, 6 multiplied by 3 raised to the power of 5, 2 raised to the power of 5. We have 3 raised to the power of 5. This is 3 raised to the power of 5, not 35. Take note, 3 raised to the power of 5. That is T6 equals to 1,458. So the system, therefore, the system is this value, 1,458. 1,458 is the system of this particular question. So you can see how we got the response by using the nth term. By using the nth term. Now let's say we have another question where we are given the sequence 4, 12, 36, ... And we asked to find the seventh term. Find the seventh term of this question. Find the seventh term of this question. In this case, we have 4, 12, 36, and we want to get the seventh term of this GP. The seventh term of this GP. Permit me to wipe the board so we can take the next. So if you have 4, 12, 36, ... What we are trying to say is that A is T1, this is T2, this is T3. Take note that T1 is the same thing as A. So here we have to get the ratio, which is T2 over T1, and T2 is 12, T1 is 4. That means the ratio is 3. The ratio is what? 3. So we can solve question using this ratio, that the seventh term that we are asked to find, that's T7, we have to find T7, is expressed as T7 equals to AR n minus 1. T7 equals to the value of A given in this expression, A is equals to the first time, which is 4, and R equals to 3. So we have A to be 4 times 3 raised to the power of n. In this question is the seventh term that we have to find. So n equals to 7. We're going to have 4 multiplied by 3 raised to the power 7 minus 1. That is 4 times 3 raised to the power 6. 3 raised to the power 6. That is 4 multiplied by 3 raised to the power 6. 3 raised to the power 6 should give us 729. 729 multiplied by 4, that is 2,916. So the seventh term of that question is 2,916. And you can see it shows a progression. The higher the term, the higher the value. The higher the value. So this is another question solved under the nth term of a GP. Under the nth term of a GP. Under the nth term of a GP. Now let's consider the sum of a GP. The sum of a GP. Permit me to wipe the board. Question number 3. Want to look at the sum of a GP. Let's take a pause, please. Once again, if this is the first time that you are watching our videos, please do well to click on the subscribe button. Do well to click on the subscribe button. Thank you as you do that. Now let's continue. Question number 3. Question number 3, we want to consider a question that has to do with the sum of GP. The sum of GP. The sum of GP. Now let's consider a question on that. But all before that, we need to know the formula for the sum of GP. The sum is given as xn equals to a into the bracket 1 minus rn over 1 minus r. We have two formula. The second one is xn equals to a into bracket r raised to power n minus 1, close the bracket, all over r minus 1, all over r minus 1, all over r minus 1. So these are the two formula we'll be using, but they have conditions and some things we need to consider. When your ratio is greater than 0 and when your ratio is less than 0. When your ratio is greater than 0 and when your ratio is less than 0, makes the formula to be different. Make the formulas to be different. So when your ratio is greater than 0, when your ratio is greater than 0, when your ratio is greater than 0, you use the first formula, and when it is less than 0, you use the second formula. You use the second formula. Now let's go ahead to solve a question under sum of GP. Under sum of GP, sum of GP, sum of a GP, sum of a GP. So the question we are going to take under that is this question. We are asked to find the sum of a GP. Find the sum of the first. Find the sum of the first. Find the sum of a GP. Find the sum of a GP for the first 4 term. For the first 4 term, the first 4 time of a GP whose term is 5, whose first term is 5, whose first term is 5, and the common ratio is 1/2. So this is the question we want to solve. Find the sum of the first 4 term of a GP whose first 5 term, whose first term is 5, whose first term is what? 5. So we have this information. The first term is 5, and we are asked to find the sum of the first 4, and the common ratio is what? 1/2. So there is a condition to know which formula to use. If r equals to 1/2, we have to know whether r is greater than 0 or less than 0. So of course, r is greater than 0. If r is greater than 0, we'll be using xn equals to a into bracket r raised to power n minus 1 all over r minus 1. R minus 1. So substituting this value there, we have n to be equals to 4. We have n to be equals to 4. Then we have the first time, which is a, to be 5. We have the first time, which is a, to be 5. And the common ratio to be 1/2. So I need to substitute all these inside the formula that I've written out. I need to substitute that inside the formula. That's going to be x4 equals to 5 open bracket, 5 open bracket, 1/2 close bracket, raised to power n minus 1, raised to power n minus 1. So we have n minus 1, n minus 1, that is r, that is n minus 1, and n in this question is 4. So I have this expression over the denominator, which is 1/2 minus 1/2 minus 1. Sum of 4 equals to 5 multiply 5 multiplied by, expressing this, we have 1/4, 1/4, 1/4, 1 raised to power 4 is 1/4 over 4/4. So that's going to give us 1/4 raised to power 4 is, sorry, that is 2. 2 raised to power 4 is 16. So 2 raised to power 4 is 16 minus 1, close the bracket, over, subtracting 1 from 1/2, that is going to give you a negative value, which is minus 1/2, minus 1/2, minus 1/2. Or take note, r is not greater than 0, but it is less than 0. R is greater than 0, but less than 1. So the comparison we are supposed to be using is the comparison of 1. That is, R is less than 1. That's what we are comparing. That's the comparison we are doing. So if that's the case, I need to correct the formula. If R is less than 1, if R is less than 1, we have this. We're going to have 1 here minus R. Then this place we are going to have 1 also, R raised to power n. That should be the correct formula. So we need to correct this solving. So we're going to have it solved here. That is x4 equals to a, which is 5 in bracket 1 minus 1/2 all raised to the power of 4, close the bracket, over 1 minus 1/2. So that will give us 5 in bracket 1 minus 1 raised to power 4 is 1 over, then 2 raised to power 4 is 16. So we have that over. Subtracting half from 1, the answer is still half. So we have to simplify the more so we can get the answer. So to do that, we'll proceed by saying, taking 1/6 away from 1/6 subtracted from 1 minus 1/6, 1 minus 1/6, that is 15/16. 1/16 subtracting from 1, we have 5 into the bracket, 15/16. Okay, So it's divided by 1/2, which you know that we have to change that division to multiplication. That will be the next thing we are going to do. So let's use this portion of the board so we won't clean anything. Multiplying 5 times 15/16, that is 75/16. Change this to multiplication, that is times 2/1. So multiply this 76/16 by 2/1. We are going to have the final answer to be 75/8. 75/8. So the sum of the first four terms is 75/8. The sum of the first four terms is 75/8. So this is the question that we have solved under the sum of GP. We'll take one more, then we'll go to the sum of infinity. Sum of infinity. Permit me to wipe the board. Don't forget we said we have two formulas for sum. When we have a into bracket 1 minus r raised to power n over 1 minus r, this is use this when r is less than 1. And the second one is a into bracket 1, or sorry, r raised to power n minus 1, close the bracket, all over r raised to power n, sorry, all over r minus 1. Use this when r is greater than 1. So these are the two criteria you have to check. When the common ratio is greater than 1, you use this formula. When it is less than 1, you use the other formula. Now let's take one more question on that, on the sum of a GP. Let's take one more question. Given that a equals to 2, r equals to 2, a equals to 2, r equals to 2, find x5. That is, find the sum of the first 5 times. Okay, solution. Now you need to check r equals to 2 and 2 is greater than 1. So that means I'll be using this formula. That's the second formula. I'll be using this formula. We have S5 equals to a into bracket r raised to power n minus 1, close the bracket, over r minus 1. X5 equals to a. The value of a that was given is 2 in bracket. That is 2 in bracket. R is what? R is given to be 2 raised to power. Your n here is going to be 5. That's what we have here. Your n is 5. So we have r raised to power n, which is what? 5 minus 1, all over 2 minus 1. Simplify this. You have 2 into bracket 32 minus 1 all over 1. Because 2 raised to power 5 will give us 32. 2 raised to power 5 will give us 32. So subtract 1 from 32, we have 2 times 31 over 1, and multiply 2 by 31, 2 by 31, we're going to have 62. We're going to have 6 and 2. So the sum of this geometric progression is 62. The sum of the first 5 times, which is x5, is equals to 62. Is equals to what? 62. Now let's consider the sum to infinity. The sum to infinity, that will be the third part of this particular topic. And the next class will be taking UTME questions that are related to geometric progression. So this is how you get the sum of a GP, which is geometric progression. So please, if peradventure you have questions based on what we have solved, Do well to drop it in the comment section. Now let's take sum to infinity. Sum to infinity. Wipe the board and we'll take the sum to infinity. Sum to infinity. Sum to infinity. Sum to infinity by the symbol this. So what is the formula for sum to infinity? It is x infinity equals to x to infinity equals to a over 1 minus r. So we have just one formula for the sum to infinity, where a is the first term and r is the common ratio, the common ratio. So now let's take a question on that. Given that we have this expression, we have a GP, given this GP, that we have 4, 2, 1, dot, 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 and we are asked to find the sum to infinity. First, you have to identify your first term. The first term is 4. We have 4. R, which is common ratio, is T2 over T1, where this is T1 and this is what T2. So T2 is 2 divided by T1 is what 4, and this will give us 1 over 2. So the common ratio is 1 over 2. Now bringing that to the formula, we have sum to infinity equals to a, which is 4 over 1 minus 1 over 2, and that is sum to infinity equals to 4 over subtracting 1 over 2 from 1, that is 1 over 2, and that's the same as 4 divided by 1 over 2. Sum to infinity, we have 4. Changing division to multiplication, we have times 2 over 1, which is 8 over 1, and the answer is 8. The answer is 8. So the sum to infinity for this question is 8. The sum to infinity is 8. So this is how we also solve for sum to infinity. So from this class now, we have been able to explain the concept of geometric progression, and we went ahead to explain the formula of geometric progression, which is the nth term. We talked about the nth term of a GP. We talked about the sum of a GP. I also talked about the sum to infinity. We talked about nth term of a GP, the sum of a GP, and sum to infinity of a GP. And we're able to solve like some example on each of these particular formulas. We're able to solve some example under each of this formula. So to make a recap, I'm going to rewrite all the formulas again. So we're going to have it as a summary. Permit me to wipe the board. Today, we've been able to talk about the following formulas. The first one is the nth term of a GP, which is expressed as Cn equals to ARn minus 1. And we also talked about the sum of a GP, sum of a GP, which is expressed as Xn equals to AR open bracket n minus 1 over r minus 1 when r is greater than 1. And also the second is this given as a into bracket 1 minus r raised to power n, close the bracket, all over 1 minus r when r is less than 1. When r is less than 1. And we also talked about sum to infinity, sum to infinity, sum to infinity, where we said x infinity equals to a over 1 minus r. So these are the formula that we discussed, and we're able to take some examples under those formula. We're able to take some example under those formula. So these formula are very important, and you need to know it in mind. You need to know this formula in mind because you'll be using it mostly to solve your question. All right. So have it in mind. Next class, we are going to solve questions on UTME that has to do with geometric progression. That has to do with geometric progression. Okay. So please do not forget that you have access to our A1 Tutor app. It's free. For you to practice more questions, do well to download A1 Tutor app. You have access to lesson notes, you have access to video lessons, you have access to unlimited past question with solutions and explanations. You have access to the live class also. So do well to download A1 Tutor app. If this is the first time you are watching us on YouTube, if you don't know about the app is called A1 Tutor app, available on iOS, available on Android. Download it and make use of it very well. It is free. All this package at no cost and no hidden fees. You use the app freely and you learn smartly. Don't forget also to always subscribe on our YouTube channel. Do well to give us a thumbs up on the YouTube channel also. Drop your view, drop your comments, and drop your question in the comment section. Thank you for your time. Next week is another time, and we are going to have another series of classes starting from Monday. Ensure you make yourself available. Do not miss any part of this UTME crack. Do not miss any part of this live class. Thank you, and see you next time. Bye.